Quick recap. Last episode, we saw the classic Wagner curve for pressure-dependent demand getting stuck on a sharp corner. Tanyimboh smoothed the curve and helped a lot. But smoothing is not the real fix. Today, we show the fix that actually works. Every pressure-dependent solver asks one of two questions. The classic approach, which is what Wagner, emitters, and Tanyimboh all use, asks, what demand fits this pressure? You give the solver a pressure, it hands you back a flow. In 2021, Ezio Todini proposed flipping the question. Instead, ask, what pressure fits this demand? You give the solver a flow, it hands you back a pressure. Same network, same physics, same final answer. But the solver walks a completely different path to get there. Here's the easiest way to picture it. Imagine a hiker lost in fog, trying to find the lowest point of a valley. Method 1. Look at the slope right where you're standing and step downhill. Simple. But if you hit a cliff edge, the slope breaks. You don't know which way to step, you freeze. Then you overshoot. That is Wagner at the corner. Now method 2. Instead of walking based on where you are, walk toward where you want to end up. You set a target, the bottom of the valley, and the terrain adjusts to your path. No cliff problem. You always know which way to move. That is what Todini's inversion does. Same valley, same lowest point, same final answer. But the solver simply never trips. In practice, this means the inverted approach can solve networks that classical methods refuse to finish. Crisis simulations with valve closures or main breaks. Sequential isolation studies. Contamination response modeling. Large networks with pressure sitting right at the boundary of zero. Todini's inversion is the mathematical foundation behind the most robust, pressure-dependent solvers working today. The ones that finish when classical methods give up. 3 moves, 1 story. Wagner started pressure-dependent modeling. Tanyimboh smoothed the curve. Todini made it reliable. If you want to see this architecture running on real networks, Transparent Blue Water is building it into our tools. Thanks for staying with the series. Subscribe to stay with us for what's next.